I think, right?
Yes, sir. Yes, sir.
Yes,
Yeah, I
sir.
have shown. Yeah, well, now we become a little practiced in doing this work. Uh, so going back to the previous slides, the design process is very important, and even for the examination also it is very important. I told you already. I have explained the recognition of need for what I have to do this design, and get a complete picture of it and what is the definition of the problem. So define what the problem is and do the synthesize. The synthesis is modeling it and giving the input parameters and modeling it and doing the analysis in a suitable software or by using some other conventional method, and look at the optimization, then do the evaluation against the given input parameters, and if there is a small change, again you go for the synthesis, analysis, optimization and evaluation. So these four important stages, synthesis, analysis and optimization, evaluation, are highly iterative in nature, so that we say it is a design, the Shigleys iterative procedure, or simply we say a design procedure or Shigleys design procedure. Okay, once after that we are going to present it and document. That is what I have explained in the previous classes. I hope you understood and you are remembering it. It is very, very important. Now come to the applications of computer for the design. The other topic, geometric modeling, engineering analysis, design review and evaluation, and automated drafting. So this is quite resembles. There is a small, or you can say it is following this design, the Shigleys design procedure, iterative procedure. Now in this, you can look at the geometric modeling is as good as synthesis. The synthesis, what we do in the synthesis, so by looking into the given parameters, we are going to create a 2D or 3D model of the object. So this is what the geometric modeling. And engineering analysis. Engineering analysis is we are going to do the analysis. Okay, this I will be explaining it. Design review and evaluation. It is as good as evaluation, and automated drafting is as good as presentation and documentation. Okay, so kindly look into these four important points: geometric modeling, engineering analysis, design review and evaluation, and automated drafting. Now, in a few words, this is what the comparison and relative comparison between the Shigleys design procedure and this one, what stage it is, quite resembles to this I had given. And now let me come to the geometric modeling. What is this geometric modeling? The geometric modeling, already the interactive computer graphics, it is a suitable one through which the designer will be interacting with the computers. Now here, to create the model, he is going to use so many input devices. Maybe it is a keyboard, or maybe it is a joystick, maybe it is a digitizer board. By all other these means, or even by having a panel board, just like we are having a CNC and DNC machines, we are going to do the coding by using a very specific type of input parameters. This is so by all these means we are going to do the inputting. And this, for example, please do not get confused. I am going to create a line. For example, I am going to create a line. So for creating the line, I am going to select suitable commands, and we are going to create this line onto the screen. And the line which is created on the screen will be equivalently converted into a mathematical form, and it will be stored into the computer. And whenever you are going to call it, again these mathematical forms will be converted into geometric models, and it will be displayed on a CRT tube. You are understanding me? Geometric modeling, it is a method by which it is an interaction between the computer and the human being or human designer. And here what the designer do is he will be using the specific commands to create the designs on the computer's screen. And once the the geometric model has been created on the computer screen, and that will be stored in the CPU in the form of mathematical models. So please look here. If you have created a circle of diameter 50 mm, the circle of 50 mm diameter will not be stored as it is in the CPU. It will be stored in the mathematical form. It will be stored in the mathematical form with certain informations. When you call for these mathematical forms, it will be converted into geometric models and it will be displayed onto the CRT screen. This is what. Okay, and now that is what in the first beginning I have given, and let me come to the geometric model design or construct the geometric CRT script by three important commands. Okay, so how he is going to create the model? So he is going to follow the three steps. For example, I want to create a rectangle. You say, I want to create a rectangle by using your CAD software. What you are going to do? You are going to create the lines. The lines will be created, and we are going to for example, a rectangle for 100 mm by 50 mm. I am going to call the line onto the screen, or I am going to create a line onto the screen. I am going to scale it, and again 50 mm I have to do vertically. So again scale it and reorient, rotate it. And what I am going to do is I am going to create four lines. One is of 102 of 100 mm and another two of 50 mm. And all these will be joined together to create the rectangle. That is what I want to do explain here. First, the designer is going to create the entities. The entities may be line, points, and circles. Okay, this is whatever suitably you are going to create the 2D geometry. So suitably you are going to call the entities. Entities are those cannot be edited. A part of it. Once you want to delete, the circle will be deleted once at a time. The line will be deleted once at a time, and point will be deleted once at a time. So it is not editable. Okay, so these are called the entities, and these entities you are going to call them onto the screen, and we are going to do certain transformations. As I told you here, I am going to create a line of 50 mm. I am going to create a line of 100 mm, and I want to create the created line 50 mm. I want to orient it. So while you are going to do the orientation, we are going to displace the line and we are going to rotate the line. This is what the second command type of use to for accomplishing this is a scaling, rotation, and the scaling, rotation, and what transformation, translation. The translation, scaling, and rotation, all these are the three important transformations we are going to do. The third one is that we are going to create a model by using these entities. Okay, and we are going to store them into the computer, and these entities, the geometry what we have created, that will be stored in the mathematical form in the computer. And when you are going to recall it, again these mathematical models will be converted into the 2D model what you have created, and it will be displayed over the screen. This is what. And there are several methods by which you are going to create the model. And here I have given, I have not explained it, 2D, 2.5D, and 3D. So we can create a model, a rectangle, just you know that 2D is just a line sketch. And 2.5D is just it is highly it is extension of the 2D modeling, slightly lower than the 3D modeling. Here the model appears to be 3D model. Only for the appearance purpose, the third view will be attached or made to be visible. The third way we are not going to do anything. That is called 2.5D. Just we are going to show a 3D model in order to realize what the model is. But we are not going to do any kind of, or we are not going to create any kind of information in the third dimension. That is what called as 2.5D. The 3D is all the three ways, X, Y, and Z informations can be fed into, and this will be created as a mathematical model in the computer, and it will be created on as a graphical model on the screen. So in total, the geometric modeling is the human designer will be operating the computer. That means he will be interfacing with the CRT tube and the computers by means of a keyboard or some other input devices. By using the input devices, the designer will be creating the entities, and he is going to do some kind of translation, the transformations. The transformation may be scaling, rotation, and translation. Translation is moving this entity on the screen suitably wherever it is required. Okay, I want to create 4 lines of rectangle, then we are going to join them through a suitable method, that is translation. And the scaling and rotation, all these 3 transformations you do, then he is going to do a joining of all these, that is he is going to interconnect them to create the model. The models may be, there are 3 methods I told you. The first step is going to create the entity. Second step is he is going to do transformations, and the third he is going to do assembly of all these entities in order to give a pictorial view of a required 2D the object. And there are 3 important methods by which we can display the object onto the screen: a 2D, 2.5D, and 3D. 2D is just now I had given example of a rectangle. This is the 2D. Understanding? You are using. Am I audible to you?
Yeah, sir.
Yeah.
Yes, sir.
And 2.5D is just the extension of 2D. Here in this case, the third dimension is added only to visualize the object. We are not going to do anything with the third angle, third dimension. And the 3D is all the 3 dimensions, just like isometric and obliques. We have already created in the first semester. Those can be created. We can able to visualize and get the information about the first the X, Y, and Z informations. So this is about the geometrical modeling. And I hope there is no doubt in this. Engineering analysis. So engineering analysis in this, once the model has been created by inputting the parameters, I have to go for the analysis. And now once you please look here, I have created a rectangular slab. I have created, for example, a square slab of 20 mm square and 100 mm length. I wanted to do the analysis whether it will carry the load or not. By giving the end support at the midpoint, I am going to apply the load. Now here the input parameters are those, what is the material property? What is the material? Correct, no? So this 20 mm square of 100 mm length, I may create it for the wood also, I may create it for the steel also. And I have to give the input parameters. This is a steel or a wood. In what way I am going to give? So already in the 3rd semester we have studied the stress strain analysis by using the universal testing machine. So this input, the Young's modulus of the material will be inputted. The Young's modulus will be taken care of the material in this. Okay, and I may have to often go for the stress strain calculation, or I have to go for the heat transfer calculation, or I have to do some other calculations. Okay, what is required. Okay, and now most specifically to do the analysis, often we are going to use the finite element analysis softwares. The finite element analysis softwares, I am not going to discuss more about the FEM, and ADM softwares, automatic dynamic analysis of mechanical systems. So here we are going to create the 3D model. For example, I have created a mechanism. I wanted to see anywhere any interference is there or not. For example, I want to, I have created 4 linkages. I want to rotate them, and interference means they are colliding any points. They are colliding any other points. That also can be estimated. LS Dhyana is one software. We are going to do the impact analysis. Impact software it is. Just like that, so many softwares which are available, and optimization of the route for the assembly. A very important thing. You can look at the engine is having a lot of very complicated assemblies, and once it is very easy for me to disassemble it. And once you go for the assembly, and so many nut and bolt will be lying down on the earth, on the side of you, where it has to be assembled, you will not be knowing it. And sometimes some bolts you want to do the assembly, you will not get the space to do the assembly. That is a wrong method by which you are going to do the assembly. So the route by which we can able to assemble the different subparts to the main part also can be optimized, and we can able to visualize by using the design engineering analysis softwares. Okay, this is about engineering analysis. So once again, the engineering analysis, once after creating the 2D or 3D model of the object, the engineers the analysis person or a designer has to do, may have to come across many other analysis. Maybe it is the strain analysis, heat transfer analysis, and so many other specific analysis. Maybe it is impact analysis. Okay, whether it will carry the load or not, that analysis you want to do by using a very the specific softwares like FEM softwares and CADM softwares, LS Dyna, and sometimes the place, position layout and cell evaluation, which I have not given here. The position layout and cell evaluation is one analysis. I can able to create the entire factory on our screen, and how the material is flowing from one station to the other station also I can able to visualize, and where it is having problem and time lapse. All these can be estimated and analyzed by using the place software, position layout and cell evaluation. Like that, so many specific softwares are available. By using these softwares on this model, the engineer is going to do the analysis. So if you cannot able to do, if you cannot able to remember the design analysis is by using specific the softwares like FEM softwares and less Dyna and some other heat transfer analysis, the stress strain calculation, etc. The design engineer will be doing by using in this section. Now, design review and analysis. What is the design review and what is analysis? So the design review is called, now here, once the designer has created, he has done the analysis. Please remember, once the designer has created, once he do the analysis, the drawing which he has created has to be ready for the manufacturing. Once the ready made or the drawing has to be ready for the manufacturing, he has to think about interference of the assembly. He has to think about the limits, fits and tolerance of the assembly, and he has to look into all the aspects which will not be again come for the maintenance tomorrow. This is what I am going to look at. So the designer will be checking into the accuracy of the design, and he is going to do possible dimensional errors. He is going to identify and do small error analysis, optimize it, and he is going to do zooming of the part and look at any interference is there. And sometimes the second point which I have given, the procedure called layering, helping you for the design review. So the layering is what, for example, you have created one part in the one paper and other part in the other paper, and we are going to laying one paper or the other paper, looking at whether these two are assembling or not. Just like in this design review also, the layering is possible. The layering option is possible. What he is doing is he has created a part already in one directory, and he is going to do create other part in other directory, and now he wanted to see whether these two are assembling or not. So he can call for the option called the layering, and these two layers will be lapsing one or the other, and he can able to merge, and he can see any dimensional changes, errors are there. It is also possible, and he can do the interference checking. Okay, interference checking, and sometimes the last point which I given, the kinematic analysis also can be done. The kinematic analysis is what just now I told you, the ADM, automatic dynamic analysis of mechanical systems. He can create the different models, he can rotate, and he can visualize where the two linkages are clashing each other. That also can be visualized. This is called the design review. And analysis is what already I told you. The analysis is that once after the design review completed, the analysis is he is going to compare the output of this software with the input boundary conditions. On what boundary conditions? For example, I wanted you to go to the market, get me 1 kg of tomato costing you 20 rupees. So you are going to find out the tomato and you are going to take the 1 kg. Now you are going to do the analysis. What is the analysis? What is the cost of the product and what is the cost I have expected earlier? 20 rupees. You are going to compare it. This is what. If it is 21 rupees, you are going to next customer, next person, salesman. And if it is 19 rupees, it is well within our limit. We are going to accept it. just like analysis is, and automated drafting. And now in this section we are talking about automatically we are going to create the drawing of the object. So here the errors will be avoided once we create the sectional view of the object we are going to create, and we are going to do assembly and create the sectional view, and we can able to create the automatic drafting, and wherever possibly we require to create the dimensions, all these possibly we can able to automatically do in the softwares. Okay, and now if you want to show some part which is not visible to you, for example, a shaft of the 1 meter length and diameter is only 50 mm. I want to show key dimensioning. That particular portion where we want to enlarge, you can enlarge and show the dimensioning. That is also possible for the viewing purpose. So for the manufacturing, these automated drafting will be very, very important. Okay, in automated drafting, automatically the drawings will be created by giving the manufacturing suitable dimensions. That means the limits, widths and tolerance and dimensioning, and to visualize more the cross-sectional view with the dimension, and to suitably more, and we can have the assembly section and skirt section. All these can be created automatically in the automated drafting. So any problems you want to discuss in this section? Kindly remember the application of computer for the designing. Geometric modeling, we will create the geometry of the models. Maybe it is a 2D, 2.5D and 3D. 3 stages we come across: calling the entities and transformations. Maybe it is a translation, scaling we do, and create the model. And the third step is design review and evaluation. So we are going to impose this particular 2D or 2.5D or 3D model for the analysis purpose. Once you do the analysis and by using the specific application software, maybe it is a FEM software, analysis software to do the calculation of stress strain, to do the calculation of heat transfer. Okay, it may be a CFD analysis, computational fluid dynamics, how the fluid is flowing, how the exhaust gases are flowing, so what is the temperature in the compression chamber, how the fuel is mixing, and what is the agitation, how it will be taking place, what is the pressure and the temperature and the atomized particle sizes. So all these analysis can be done by using these specific softwares. Now today we have many softwares are available in the market. By using them we can do the design review and evaluation, is comparing the output what we got from the software with the input parameter what we required. Then once after that we are going for the automated drafting. Automated drafting is the manufacturing drawing. What is the purpose of going for the design? We are going to create the manufacturing drawing. So creating the manufacturing drawing, here automated drafting will be created itself. So the designer has to opt for the different options. He wanted to have the hatching, he wanted to have the zooming of the part and look into the dimensioning, and he wanted to have the assembly of the part and hatching and sectioning. All these are possible for the visualization to correct ourselves by some of the confusions, and you know to create the manufacturing drawings. Now the drawings are ready for the manufacturing and automated drafting, and it can be sent for the manufacturing purpose. You understood these 4 important points? I hope understood. Please, one of you tell me.
Yes, sir.
Yeah.
Yes, sir.
So this is very, very important for the examination point of view. I'm not simply telling you important, very, very important. Engineering, okay, all these you have to in a very systematic way remember: geometric modeling, engineering analysis, design review and analysis or evaluation, and automated drafting. These are the 4 important steps, or these are the benefits of the computers in the design. Now, what are the benefits of computer-aided design? So this is generally I have taken very important points. The benefits of computers in design: productivity improvement in design. So the design productivity as well as the designer productivity will be increased, since we are going to use the computers for the creating the geometry, analyzing the geometry, evaluation of the geometry, and finally presentation of the geometry and giving the manufacturing drawing. All these will be taking not much more time. So the productivity improvement in the design and the design station will be very effective. And the design analysis. So in the earlier classes also I told you, if you have to do manually, a prototype of the design will be created and it will be led to the destructive or non-destructive testing. Now a simple example I had taken, a stress strain analysis of our specimen. So the stress strain analysis of the specimen, you have to take a rod, get down to the required dimensions and do the machining and hold this into the universal testing machine and conduct the experiment and get the informations. And it will not be taking a few minutes, it will be taking a few days or a couple of days. Okay, it is a destructive testing. And the design analysis can be done by using the specific softwares in the computers aided design. So it will not be taking much more time. This is one of the benefit. And fewer design errors. Since now our mind is restricted only to our classes. Once you have to go for a complicated design, just like Volvo engine, analyzing the engine itself will be taking years together for us. Please understand, it will be very complicated in nature in understanding the drawings. So understanding the drawing, it will be taking a lot of time. If you have to create the sub assembly for this main part, how many errors will be creating, or it will be done chaotically by the human designer. You please understand. So all these design errors will be eliminated by using the computers. This is fewer design errors. So definitely the errors will not be nullified. 100% it is not possible. So due to the input parameters which are given by the human designer, there will be small errors. Those have to be the encoded design errors may have to be analyzed by human designer and he has to correct them. And greater accuracy in design calculation. So the design calculations and the accuracy will be higher extent because the computer will be doing it. And the standardization of design, drafting and documentation procedure. And since we are going to take the benefit of the computer design in the computer integrated manufacturing, it is globalization. As I told you, if there are 4 parts to be assembled to the main part, and totally the main part and 4 assembling part, there are 5 parts will be designed and fabricated, manufactured at 5 different companies. In the 5th company, the assembly will be done. So you can see that it is possible to have a standardization of design, drafting, and documentation is possible only by using the benefit of computers. Okay, drawings are more understandable since we are following a standard design procedure. The drawings are more understandable by the viewers and improved procedure for the engineering changes. So engineering changes means what? Improved procedure for engineering changes. That means any changes are required to be done because the design is iterative in nature. Today we are going to do some design and tomorrow based on the market requirement we are going to do small changes with the material by keeping into some parameters into mind like material or aesthetic view or the strength view. All these may be taken into account and already which has been stored in the database, that drawing will be recalled and suitable corrections will be made. So this improved procedure for the design changes is possible in the computers by using the computers. This is one of the benefit. And very important thing is the manufacturing benefits. See, just if you go to the in non-season, you are going to take a bike. The bike rate will be 50,000 rupees, for example. And in some other the options like some seasons, Diwali, and some other very occasional occasions, the bike rate will be 49,000 rupees for some benefits. It will be given one free stove or something like. So here, by creating all these, by performing all these, geometric modeling you are going to do, analysis you are going to do, drafting you are going to do, evaluation you are going to do by using the computers. Some benefits what we get is the manufacturing drawing. automatically the manufacturing drawing will be created, the dimensional chart will be created, and all these other the additional benefits which will be required for the manufacturing, a bill of material, the sub-component dimensions, the sub-component types, and assembly drawing, and so many other things which are created automatically. The designer need not to create, the computer will be creating. This is one of the most important benefit by using the computers in the design. You understood? The productivity improvement in the design, design analysis, fewer design errors, and greater accuracy in the design calculation, standardization of design, drafting and documentation procedure. Drawings are more suitable and they are more understandable. Improved procedure for engineering changes and benefits